obvious solution is science with me. Science with me. Science with me. Come, let's do some science with me. Together let's hypothesize, experiment, and analyze. We will have sex on. Hey, science with me. Science with me.
Atomic structure. An atom is the smallest particle of an element that still retains the chemical properties of that element. An atom is made up of 3 subatomic particles: protons, neutrons, and electrons. How these subatomic particles are arranged gives each atom its individual properties. The nucleus of the atom is made up of positively charged protons and neutrally charged neutrons. The neutrons help to hold the nucleus together by stopping positively charged protons repelling each other outside of the nucleus. Negatively charged electrons orbit the nucleus in the electron cloud. The electron cloud is an approximation of where the electron might be found at any point in time. The number of positively charged protons in the nucleus equals the number of negatively charged electrons revolving the nucleus, so the charges cancel out exactly and all atoms are electrically neutral. To see atoms, a special kind of microscope called an electron microscope is used. The number of protons in an atom determines the atom's identity and is given a special name called the atomic number. Each element has its own atomic number. For example, hydrogen has 1 proton, helium has 2 protons, and carbon has 6 protons. There is no way a carbon atom can have 7 protons, because if it did, it wouldn't be carbon anymore. It would be nitrogen. The periodic table is a list of all the elements ordered in increasing atomic number. Atoms are so light it is not convenient to express their mass in kilograms or grams, so we use a new unit of mass called the atomic mass unit, AMU. The proton has an approximate mass of 1 AMU, so does the neutron. The mass of the electron is so small we ignore it when calculating the mass of the atom. Just the number of protons and neutrons are added together. The number of neutrons in an atom can be found by subtracting the atomic number from the mass number. When scientists write information about elements, they use elemental notation, which consists of the element symbol, the atomic number, and the mass number. As we have just learned, the number of protons in an atom can't change, because if it did, then the element wouldn't be itself anymore. It would be a different element. However, the number of neutrons in an atom can change, and when this occurs, we end up with a slightly different version of the same element. Atoms with the same number of protons, i.e. the same atomic numbers, but different number of neutrons, i.e. different mass numbers, are called isotopes. Isotopes have the same chemical properties as the number of electrons are the same, but slightly different physical properties. Many elements that occur commonly are made up of isotopes. For example, hydrogen has 3 isotopes. As you can see, the more neutrons that are added to the atom, the heavier it gets. Now you know that. An atom is the smallest particle of an element that still retains the chemical properties of that element. An atom is made up of 3 subatomic particles: protons, neutrons, and electrons. The atomic number of an element is the number of protons in an atom of the element. The mass number of an element is the number of protons and neutrons in an atom of the element. Isotopes are atoms which have the same number of protons but a different number of neutrons.
Hey, science with me! Science with me!